So now comes the logical address and physical address. Actually, logical address is something which is some address which is actually generated by a CPU. CPU actually generates a logical address, while the address which is actually available over the main memory is the physical address. Okay, 0 to maybe 8000, right? This is the physical address. 0, 1, 2, 3, 4. These are address locations over the main memory. So logical address is generated by CPU, also referred as a virtual address. Sometimes you, not in this chapter but maybe somewhere else, you can also see the term virtual address is used instead of logical address, while the physical address is the main memory address. Okay, logical address is actually mapped into physical address during the execution using MMU, memory management unit. Okay, mapping of logical address to physical address. Okay, so here's MMU already. MMU is shown in this picture. That it is actually a hardware device that at runtime it manages the addresses coming from CPU to the physical address. Okay, physical address over the physical memory. So this is what the memory management. Now this memory management is done using several schemes. Those schemes are contiguous and non-contiguous. So you remember that memory management unit use several schemes to manage the memory space, right? There are two type of memory management schemes, allocation, memory allocation schemes. The first one is the two categories, basically the contiguous and the non-contiguous, which I have already shown in you in the introductory slide. Okay, so now memory management, how this memory management is actually achieved. The basic concept of memory management is shown here, where you have, for suppose a logical address is 346, while the relocation register, which means the base location, right, the base location is 4000. For suppose here this is the base and it is 14,000, right? Sorry, not 4,000, 14,000. Now what? Now this is the base location and this is the limit location. This is base location and this is the limit location. Okay, now this relocation, because at the runtime we don't know, sometimes it's here, sometimes it's here, or sometimes it's here, sometimes it's here, so we call it as a this address as a relocatable address, because every time this relocatable address see the occupied spaces and then decide that it should go or not. Now here we see two symbols, the less than symbol and the greater than symbol. When we say when we are comparing the base, then we say that whatever new address is coming is added into this relocatable address. For suppose it's 14,000, then 14,000 plus 346, it would become 14,346. Now we'll see that 14,346 is greater than base. Okay, oh, now base is 14,000. Yes, it's greater, right? It's greater. Okay, and limit. The next thing is limit. What we see that this, when we are adding this 14,346, 14,346 is less than limit. Yes, if only these two conditions are true, then only this mapping can be done if these two conditions are true. You can consider there is an AND operator, sorry, right, there is an AND operator in between these two. Okay, in between these two parameters we have AND operator. If this memory is greater than base and this memory is less than limit, then only you are allowed to map. Okay, then we call the mapping function here. Okay, memory mapping using the MMU. Okay, so consider the simplest scheme. I have already defined you this scheme. Okay, now we have several other things beside the binding. We have also in the memory, when we are locating the memory, we have some different type of for suppose if we are saying that we are talking about the execution time binding, then we have certain different concepts to look over. The first one is dynamic loading, and then second one is dynamic linking, and the third one is overlays. Now what are these topics? In overlays actually is not the part of your book, but it's very important, so we'll see also overlays. Now when we are talking about the in dynamic loading, then entire program does need to be in memory to execute. Routine is not loaded until it is called. So program is actually divided into monitorable modules. We know that there we do some we divide a program into the modules which can be monitorable, right? I have already told you monitors about the monitors in previous lecture. So we have a module, we have certain number of modules which can be monitorable by the CPU or by the memory management unit. Okay, at the time of execution, program must be loaded into the main memory. This is the fact, right? We know that a program, whenever we are executing a program, whenever we double click some application to run, that application is actually loaded into the main memory. And the question is that shall I load all the modules in advance before they are even called, right? For example, if there are maybe 20 number of modules, or maybe first suppose if we have a program, if I have a program here, right, maybe program 1, right, program 1, and I have several functions, maybe add, right, and its definition goes here, and maybe I have a subtract. I'm just throwing some example, right, and maybe division function, we have also the definition of division function over here, right? So we have these three functions here, and this is the program. So shall I load all these routines, all these modules in the program while I'm loading this program, or whatever required I will be loading that? So this is what the main theme, that load only the main module first. For example, the addition is the main module, or maybe some other maybe the GUI, maybe here we have also GUI method, right? GUI call init GUI, right? If I call init GUI, now this is the main module, and maybe there are some primary functions. So these two may be the primary function, these two are the primary function, while multiplication and division are not primary functions. Suppose we say that these two are not primary functions, so these two will not be loaded into the main memory. Only the main modules would be loaded into main memory. For suppose if you are saying that MS Word, we have MS Word or maybe MS PowerPoint, then when you double click that MS Word or PowerPoint icon, only the required modules such as fonts, such as style, font style, and maybe font size, and maybe bold italic functions, or maybe page break or something, and only the GUI would enable to load the remaining modules, which enable you to load the remaining modules is actually loaded into the main memory. Only these modules are loaded, right? However, if you go for the creating a content of your document, then this is very rare used. So it is only loaded when you go for that module, to access that module. Okay, so dynamic loading is when you depend on the modules. Okay, then we have dynamic linking also. What's dynamic linking? Now I give you an example. For example, here I have a program, okay, and let's say this is okay. Here here's the program, and I import maybe Java X, right? Showing that Java X, right? So I import Java X library in this program. This is a program, right? Okay, and this is the library, right? So I imported swing.javax, okay, in the system, but when I said okay, JP is jpanel JP, I created an object maybe using for the jpanel, and whenever I say jp dot set layout, maybe I'm setting some layout of my GUI, then only this layout function will be called. Okay, maybe whatever here. Okay, so whenever I call this function would be only linked at that time. This function or routine or maybe the class, whatever, whenever these functions are actually called, they are only linked at that time. Now in previously I just told you that okay, for suppose add, subtract, these are different functions, but those functions are actually implemented as the modules, and those modules actually they are their definition belong to the same program, right? We see that the addition and the subtraction and the multiplication and division, their description, their definition was inside that program, the same program, so we call it as a module. While now here we are accessing set layout function, which is not the part of this program. The definition of set layout is not does not available in this program, and we are accessing from an external library, so this thing is called dynamic linking. Dynamic linking. Okay, so the code which actually enable you for this access is the routine which enable actually the code, or maybe the routine which enable you to access this type of dynamic linking, and maybe the methods and maybe the libraries or maybe classes is called as a stub. Stub helps you to allocate to locate the appropriate memory resident library routine. Okay, used to locate the appropriate memory location, right, of the library. So I hope this is clear now. Now we have also something else, we call it as overlays. Now what is overlay? This is dynamic loading, then dynamic linking, and then okay, overlay. For overlay I will add some slide here. Okay, I will add a slide here. What is overlay? So another linking method is overlay. Okay, what is overlay? It is actually helps to manage the memory. How to manage? For example, if I have a program here, right, this program has some symbols, maybe A, B, C, or maybe some A's, or maybe some add method symbol, right? Whatever the symbols, maybe variable names or maybe something like that, names, whatever the names and the strings are actually the symbols. These has some, this program has some symbols here, and this program might have some routines, common routines. Maybe this program has some routines, right? And okay, and subtract, right? Whatever the routines, maybe routines we say functions, but it can be anything. It can be even borrowed from a program, right? And these symbols can also be borrowed from, inherited from a another library or maybe another resource. Okay, so let's say this is a program 1, right? And now we have some condition that this program goes into execution for 2 times, maybe pass 1, right, and pass 2. We have symbols, we have routines here, right? So in pass 1 this program needs maybe 60k for execution, and in pass 2 this program needs 75k for execution, and symbols are actually 20k and routines are actually maybe 35k, right? So this is what actually the total memory needed for running this program in 2 passes. Okay, now if we sum up this memory, then 35 is 55, it's 10 and 90, right? 190, whatever, let's say 190k. This total we need some the total 190k of memory to execute this program for 2 passes, right? So what happens that overlay, how the overlay helps. Now for suppose in the memory, for example, we have operating system already loaded here, and maybe we have some other applications here, right? Occupy, already occupied, right? Already occupied. Now we have only this space available here, and this space is only maybe, if this is 150, maybe this is only 160k, right? Now this space we have only availability of 160k while we need 190k. Now what will happen, that we cannot normally execute this program, normally load this program into the memory, because we don't have enough memory, right, in the main memory. So what will happen, this program will be crashing all the time. To overcome this issue, we have overlays, right? How the overlays actually works, that whatever the common routines are there, they are loaded in the memory. For suppose the symbols is a common routine in these 2, and is the common in these 2, and the routines are also common in pass 1 and pass 2. So these 2 are actually, for suppose this is 160k, I just zoom into 160k here, right? Because of the space I am writing maybe in very ugly manner, so you have to bear that. So let's say symbols are already loaded, symbols are loaded here, okay, and routines are also loaded here. Okay, now symbols are only 20k long and routines are 35k long, and we have an additional code of overlays, that's only 10k, right? Now we have overall 65k occupied by this information. Now from 165 we have 95k remaining. Now this overlay code, what's this, for what we have this overlay code, which is even occupying some 10k extra, because it is managing the pass 1 and pass 2. Now pass 1 it is 60k and pass 2 is 75k, right? Now these two will, one of these two will be given the time to spend here, right? Given the some space to come here, only one of two, the other one will be blocked for now. This will be, for suppose this will be allowed and this is blocked now. Now 65 plus 60 equals to 125, right? When pass 1 is running, we have only 125 memory space in the main memory under the use. However, we had only we had 160K and we are using only 165. It means that we are still saving, we are able to manage the memory, and we in very efficient way, and we are saving maybe 35K of memory here. Okay, and when this complete, then this will be allowed, now 65 plus 75, it will become maybe how much it will become, 70 70 140, right? 140. Now 140 out of 160 means still we are saving 10K, right? Still we are saving 10K here, right? And from the space of main memory. So this is what we call overlays. Okay, this is actually the third approach which is not given in your book.